conference. I'd like to thank everyone for coming and everyone for sticking around to the bitter end. It's a pretty good turnout for later on the last day. I think we've had an excellent program this year, and we're going to finish it off with Colin Putney, who's going to talk about Monticello and versioning stuff.
Well, with a ringing endorsement like stuff.
Okay, so we're talking about Monticello, and especially the new version that's going to be released shortly, called Monticello2. One thing I want you to come away from this talk with today is that the most important feature in any versioning system is merging. The single most important thing that makes a system useful or not. So right now, the hot thing in open source versioning systems is what they call distributed versioning. In the last few years, several new systems have been released, all of which are based on a model where everyone keeps their own little repository, and then you can push changes between the upstream repositories or your peers. That, I have to say, for open source, that's a great thing, but it all depends on having good merging. So that's sort of an unsung feature of those systems. It's kind of hard to see. This is a photo by Ansel Adams, which I happen to like quite a lot. And it shows that merging is a little more complicated than the simple merge sign that we saw earlier. In fact, it's very complicated. This is a graph of a repository that was sent to me by Lucas Ringley. And this is for a private, proprietary project that he did for a client. And this is a team of 3 people over several months. You can see it's pretty complicated. There's a little detail in certain sections. It's for this kind of complicated branching and merging going on, it's crucial that a versioning system get merging correct. It has to be done properly. Historically, Smalltalk has not had versioning systems that do this well. NV doesn't get it quite right. I talked to a fellow at Smalltalk 2007 in Argentina, who had a full presentation on a tool he had done on top of NV to make merging work properly so that he could do continuous integration. Store doesn't get it right either, as I have to gnash my teeth every now and then when I'm doing visual experiments. So this is a quick explanation of what's called the repeated merge problem. So let's say this is a graph of a few versions of a particular package. The main line is ABD, and there's some branch where someone's doing an experimental feature of some kind. If we want to include D in our experimental branch, because there's some new mainline feature that needs to be in the experimental branch as well, we have to do a merge. Now, the way that's done is by finding the common ancestor, which is B, and then taking all of the changes between D and B and applying that to E. So we get a new version on our experimental branch that has all the new features in the main one. Well, then we continue along the development of the main line. And again, we need to merge that back into the experimental branch so that the experiment isn't too far out of what's current in the main line. So again, we're going to merge. Now, what is the common ancestor? The common ancestor is D. But both NV and store don't have those diagonal arrows, and so they can only tell you that the common ancestor is B. And you have to do that merge again. So if there was conflicts that you had to sort out and any complicated stuff that might have gone on, you rattle up, you got to figure it out again. Now, Monticello does these merges pretty well. It grew out of a project that Ali Bryant and I had 5 years ago. We were doing a project together, and we needed to find some way to be able to do merges because we had our development. And in fact, we've gotten a few more features over the years, but effectively, merging is the only thing that Monticello does well. So, in designing Monticello2, we wanted to keep this does merge as well feature and take it a bit further. So Monticello2 does merges better than Monticello1 does. And it does it in a more scalable way, so you can have more flexible styles of development, and you can do things like load a package in less than half an hour. Now, I want to show a little bit about how this works in your site. So, let's go to the entire program that we're versioning, the image, all the code in the image, is broken down into what we call elements. So an element is method, class, an instance variable, class method, anything that is a kind of atomic unit of code. And you can see this is a snapshot of a particular package, and things are grouped so it's easier to browse as a human being, but the computer treats these all as individual elements. So we have a method over here. This class happens to have a pool import. There's class variables. All of these things are broken down and treated as a flat list. Now, for any element, what's in the image? Now, I should also mention elements are statements. They're just references to things that may or may not be in the image, kind of like a method reference. Now, any element at a given time may or may not exist in an image, and if it does exist, it'll have a certain state. Methods will have source codes. An instance variable will be in a certain index and slot index in the class. Any element can have kind of arbitrary state depending on what's in the image. So that state can then be captured into what we call a version. A version is, for a particular element, the state that existed in an image at a particular time, and the history of that element, the ancestors of that particular version of the element. So, let's so a merge in Monticello2 is extremely simple. Instead of all that common ancestor stuff, we just look at the two elements, or the two versions of the particular element, and we compare their ancestry. So in this case, call this a version of the method. We've got version 4 and version 7, and we want to merge them. Now in this case, version 4 is in the ancestry of version 7. So we know that at some point, a programmer was looking at 4 and decided to change it, and eventually that series of changes led to version 7. So version 7 is newer than 4, and it supersedes 4. And we know that not because of the actual numbers, but just because of the ancestry. So that means that this merge can be resolved by choosing version 7. Now, let's look at another scenario. In this case, version 4 is not in the ancestry of version 7. And version 7 is not in the ancestry of version 4, so we have a conflict. The computer cannot automatically decide for us which version is new and which one should be used. And so a programmer will have to resolve that conflict. So what we end up with is a new version of this method, version 8, which has version 7 and version 4 in its ancestry, and all of their ancestors. So now, if we do another merge at some point, either version 7 or version 4 will be superseded by version 8. And if you compare that to the merging algorithms for most version systems, this is ridiculously simple. Now, this is kind of awkward to switch back and forth, but we have to do it. So if we go back to our Monticello2, now, the thing that's a little more tricky about this is you can't just deal with individual methods all the time. you want to group these together into useful units of software. And so in Monticello2, we do that by what's called slices. A slice is some arbitrary part of the image. And the slice can enumerate all of the elements that belong to it. We can define slices in terms of packages. In Speak, we have a package info, which is kind of a hack that lets us define packages by using system categories and method categories. In VisualWorks, there are first-class packages, and we can define a slice that means that all the methods, classes, instance variables, shared variables, and so on that are in that package are in the slice. You can also define slices in other terms. A change set defines some subset of the image that we're interested in, the methods that were touched during a particular working session. And so what I've got here is there's a couple of bogus packages that I've defined with code that I can do demonstrations with. So if we look at the version that's currently loaded here, you can see this is method classes and methods that were defined using categories. So anything that's in one of these bogus categories would be part of that slice. On the other hand, we can also give a new change set, and make some changes. So, if we look in the change sorter, you see there's two methods here and a class definition. Now, those changes also affected package info sets called bogus, so that's what I was going to do. I'm going to add a change set to this. I'll save what's called a snapshot of that slice. You can browse that and see what's in. You can see that it's actually a bug here. The class definition of bogus A wasn't in the change set. And so it's not showing up in the browser here. But we can see that new class definitions. So what we can see here is that it's possible to define slices that intersect. A given element can be in more than one slice at the same time. And we can still version those slices with full history, despite the fact that they were intersecting in the lab, because the history is attached to each element. Now, so we have package info slices that I just mentioned, and change those slices. There's also something I call an explicit slice, which is just a slice that's defined by a collection of elements. I use that a lot in testing, and there's been a few occasions where I found it to be handy outside of testing. So it's something that you can use as sort of a back pocket tool. It's not something you want to use every day, but it does seem to be handy. There's another thing I call union slice, which takes a bunch of other slices and unions them together so that the elements that are in any of the slices that are contained in the union are present. And that's handy for things like several slices, several packages that make up a larger product. So I'll show you in a minute how I use that in managing Monticello itself. And this is another type of slice, which actually I haven't implemented yet. I haven't run across a need for it, but one of these days I'll get around to it, which is a different slice. So this would include all of the elements that are in one slice, but not another slice. And these composite slices can be useful for creating deployable groupings of elements. Is there a question? Okay, so get back to the speed here. Now, one thing I've done, which is a bit different from Monticello 1, is to group things together into what's called a project. A project is a grouping of slices and repositories that kind of belong together. And it really good to use Monticello 1 later. As soon as you get a lot of packages in the image, it's kind of hard to keep track of them because they're other people's packages and you know what you're working on. You don't want to be looking at them all the time and having them clutter your interface. So in Monticello 2, we create this thing called projects, and here's the bogus project with the bogus code that I've been testing with and demonstrating with. The Monticello project has the slices that are used to organize Monticello itself. And the release slice is a union slice that includes several other slices. When I want to make a release, I can just develop normally, save all my main slices, and then save a copy of the release slice, which include all the code that's included in one of those slices. So I made a few releases so far. Most of this has been just in bootstrapping Monticello itself and building, moving Monticello into new images and things like that. So I can make another release of it. And since this is a union slice, there's actually quite a bit of content. Because we have a bit of a bootstrapping problem here, I also included a file out. Any snapshot. That's what when you save a slice, it's called a snapshot. So file out a snapshot. And it's a regular chunk format file out, which can be filed back into some other approach. Now, another thing that's a bit of a departure from Monticello 1 is that projects themselves are versionable. So a project, there's such a thing as a project configuration slice. We can save a snapshot of that, and that basically just includes the project itself the slices that it contains, the repositories, and how they're configured. And I'll show you how this works. Add another change set slice. And then you can see that now this is considered dirty because I changed it. And if I load that old version, but in any case, what we can do is version projects themselves, so that if you're working with someone else and you add a slice or you add a repository, you can just save a snapshot of the project, and other people on your team can load the project. It just handles all your node configuration. And one of the things this illustrates is that Monticello2 isn't really tied to Smalltalk. It has a concept called domains. So there's the Smalltalk domain, and there's a bunch of code that knows about Smalltalk and can modify it or save state. But there's also the Monticello domain, and it knows how to work with projects and find the state of the project and save it. The image. And it's possible to extend it to other types of data. One thing I've long thought would be interesting is relational database. It would be feasible to version a schema for relational database in Monticello2, using Block, for example. Other things like CSS or JavaScript. If you have a Seaside project and you've written a bunch of custom JavaScripts, custom CSS, those things could be versioned in Monticello2 as well. And that gives you a system that can be versioned entirely in one place. You don't have to have a version author with your CSS and try to remember which version of CSS maps to which version of code. Things like that. It's okay to have this. So I guess I'm going a little fast too. That's where we are today, and hope very soon to have a stable release. There's still a few bugs there that need to be fixed, especially in the project versions of that few weeks. It turned out to be really important for bootstrapping Monticello itself, and so I was going to push that off for the release, but I needed it, so So once the release is done, we're working on documentation. A gemstone repository is also high on the list of things to do. We want to have a really solid network repository that people can trust their data in. I think gemstone is a good way to do that. And once that's in place, I want to finish the port to gemstone in the sense that we use Monticello2 to version gemstone code just as much as Squeak code, and port things back and forth between Squeak and gemstone. Now that Seaside runs on gemstone, I think there's going to be a lot of back and forth between Squeak and gemstone. Any questions? I see a lot of blank stares. I'm not sure if people understood what I was getting at or not.
How about visual work support?
I would like to do a visual work support as well. That probably a little bit further down the line. Personally, I'm really excited about gemstone. I really want to get into trying stuff out there, so that's kind of higher on my list. But yeah, it would be really good if those three platforms where Seaside runs and where more and more we're going to have portable applications between Squeak, Gemstone, and VisualWorks. It would be good if we had one versioning system that would run on all of those. And it doesn't really imply that it has to be one versioning system to rule them all. It's It's just taking me a minute to get code between my dial. Anyone else?
I want to thank all the speakers for coming, all the exhibitors for doing and sponsoring us, specifically Cincom and the two ladies, and there was a third lady. This conference and did far beyond what one could expect. So thank you very, very much for helping STIC to do this. And I also thank all of you for coming. I wish you enjoyed being here. I did. And I hope you got a little bit of what that I really enjoyed, many of the presentations. And if you have anything to let me personally know what we should better, different next year, my email address for these purposes is georg@stick.st. that I get filtered directly in the right direction, so I will work on this on spare time. And I wish all of you a safe flight home, and I will be around until tomorrow morning, 5:15, when I have to go to the airport. If someone needs a shuttle tomorrow at 5:15, there's still more room in the car, okay? So be at the Bellman at 5:15. So thank you for coming. Have a safe flight, and goodbye. Do you want to say something?
Oh, I'm waiting to turn that.
Okay, so bye-bye.